So this is our first example that introduces us to matrices. And matrices allow for an ingenious and simple method to solve linear systems that can contain any number of equations or variables. And all that is utilized to solve them is basic arithmetic. However, as you can see here, there is this ruled background because one of the hardest part of solving a matrix is simply staying organized. So the ruled paper, having ruled paper or grid paper, will help us stay structured in our work as we construct our matrices. So in this example, we're going to demonstrate how the Puffy's find pastries problem was solved. We already know that the solution for this problem is x is equal to 15, and x represented the dozen donuts. Y is equal to 10, and y represented the eclairs. And z is 8, and 8 represented the croissants. And what we're going to do is we're going to use elementary row operations to show how we achieve this solution. So here's the matrix that represents the Puffy's find pastries problem. And as you can see, this matrix is made up of columns. That's up and down here. We have 4 columns and rows. And each row represents a linear equation of the Puffy's find pastries problem. And this type of matrix is called an augmented matrix. It's actually 2 matrices smushed together into one. They're combined together. We have this vertical line here, the values over here on the left-hand side. These are the coefficients of each of the linear equations. And the values here on the right of this vertical line, these are the constants. So what we want to do is we want to change each one of these columns here, of the coefficients here, into a unit column, and I'm just going to write it down up here. A unit column, and a unit column is a column that contains where only one of the values is a 1 and the rest is zeros. So we're going to change one of these into a 1 and the rest will be zeros. And we're going to look to make this diagonal across here. We're going to make this diagonal with just 1s in it. And of course, we're going to do that using the elementary row operations here. So keep in mind that this first column here represents our x values. And for this problem, the x was the dozen donuts. This column here represents our y's, which is our eclairs. And this column here, that's our z's, and that represents our croissants. So again, we're going to want to make a diagonal here of 1s. And as you can see right here, we have a 1 right here in our z column. So since I'm going to make a diagonal, I want to switch these 2 rows right here, and that would be one of our row operations. So we're just going to swap these 2. So we'll put in 3, 4, and 2, our vertical line, 101, put in our bracket. Then I'll put in 15, 18, 12, and then 501, and then 2, 2, 1, and 58. So here you can see where we swapped these two rows here. So in between the matrices here, we're going to write down what transpired. How did we get from this matrix to this matrix? Well, we took row 2. I'm just going to write it with an R and a subscript of 2, and we swapped it. We use this double arrow with row 3. And then we put this arrow here to show that's what transpired. So to get from this matrix to this matrix, this was the operation that we used. And of course, here we have the 1 in our z column, and eventually we're going to have a diagonal of 1s here. So now what we want to do is change this column into a unit column, and we work 1 column at a time. So here I want to change this to a 0 or this to a 0. It doesn't really matter where you start, but we don't want to make more work than we have to. So I like to take the path of least resistance. So I'm just going to change this into a 0 here. And what I need to do, I'm going to take this equation here and subtract it from this equation here by a multiple. So I'm going to take row 1, and I'm going to subtract 2 times row 3. And the reason I'm going to do this is because when I multiply this row by 2, this becomes a 2 here, and then I subtract it from this row up here. So we're going to write that in. So this is what's going to transpire. put in a bracket here, and then we'll do that. So for here, 2 times row 3, 2 times 2 is 4, then 3 minus 4, that's negative 1. 2 times 2 again, 2 times 2 is 4, 4 minus 4, that's 0. And of course, 2 times 1 here is 2, and 2 minus 2 is 0, and that's the whole idea. We want to get these columns, the rest of these values to be 0. Then I'll put in my vertical line. Then 58, 2 times 58, 2 times 58 is 116. 101 minus 116, that's negative 15. Then I put in my bracket, and I fill in the rest of the values here. 15, 18, 12, 501, 2, 2, 1, and 58. So far I've got a 0 here. Now I'm going to do the same for this one. So the row operation I'm going to do here is I'm going to do row 2, but I'm going to subtract out 12 times row 3. And of course, when I multiply this by 12 and subtract it from here, this becomes 0. But don't forget, all the values within that row have to change. So we'll go over here. So now we have 2 times 12, that's 24. 15 minus 24, that's a negative 9. 2 again, 2 times 12, that's 24. 18 minus 24, that's negative 6. 1 times 12 is 12, and 12 minus 12 is 0. That's the whole idea. We'll bring down our vertical line. 58 times 12 is 696. 501 minus 696 is negative 195. Put in my bracket, and now I can fill in the rest of the values. Negative 1, 0, 0, negative 15. 2, 2, 1, and 58. So as you can see, we changed this column here into a unit column, so we're done with that column. Now we move on to another column, and if we look right up here, I already have a negative 1 or a 1 started here for my X column, so I think I'm going to go here, and of course don't forget we're looking to make this diagonal of 1s here. So I'm simply going to multiply row 1 by negative 1. And if I do that, negative 1 times this row right here, it's going to change everything positive. This is going to become a 1, 0, 0, bring in my line, 15, finish off my bracket, put in the rest of the values. Negative 9, negative 6, 0, negative 195, 2, 2, 1, and 58. Now we'll continue changing this column into a unit column. And again, you could either start with the negative 9 or the 2. It doesn't really matter. We'll start with the negative 9. So we'll take row 2 and we'll add 9 times row 1. And the reason we're going to do that is if we add 9 or multiply 9 to here and then add it to here, it changes this into a 0, which is the goal. So 1 times 9 is 9. Negative 9 plus 9 is 0. 0 and negative 6, this stays at negative 6. This stays at 0. Put in my vertical line. 15 times 9 is 135. Negative 195 plus 135, that's negative 60. Close off my bracket, and then we could fill in the rest. 1, 0, 0, 15. 2, to 1 and 58. So you can see how we're changing this into a unit column. So we'll do the same thing for row 3. Row 3 minus 2 times row 1. We'll go down here. 1 times 2 is 2. 2 minus 2 is 0. That's the whole idea. This stays 2. The next one stays 1. Bring down my vertical line. 2 times 15 is 30. 58 minus 30 is 28. Close off my bracket. Now I can fill in the rest. And now I'm done with this column. And as you can see, I have a unit column here, unit column here. Now we have to change this one into a unit column, and that will give us our 1s across the diagonal. So what we'll do here to change this to a 1 is we'll multiply row 2 by negative 1/6. So this stays 0. Negative 6 times negative 1/6, that's 1. That's the whole idea. That's 0. Bring down my vertical line. Negative 60 times negative 1/6, that's 10. Close off my bracket. Fill in the rest of the values. Now all we have to do is change this one, and then I have my unit column here, and then I'll have my diagonal of 1s here. So we'll change this. Let me put in my transition here. Now we'll change this. So we'll take row 3, and we'll subtract out 2 times row 2. 2 times 1 is 2, and 2 minus 2 is 0. That winds up being 0. So I'm going to have 0, 0, 1. Bring down my vertical line. 2 times 10 is 20. 28 minus 20 is 8. Close off my bracket. Fill in the rest of the values. And as you can see, we have our diagonal here. One value, only one value here is a 1. The rest are zeros for each column. Don't forget this represents our X, which is our donuts. Here's our Y, which is our eclairs, and our Z, which is our croissants. So now, since this is the only value within our linear equation here, that means X has got to be equal to 15, which is what we have up here. This is the only value within our equation here. That's our Y. So Y is equal to 10. That's that one here. And of course, Z then is equal to 8. So a little tedious, but as long as you stay nice and structured, nice and clean, it's very effective. And there you go.